Hello, ladies and gentlemen. Today I'll be presenting my project that I did. Just to recap some vectors, classes, and pointers. We'll be talking about basically how to utilize them in any project. So this little project that I made, this little program utilizes all of these things. It's not a really big program because it's only for 100 lines of code, but still, I think it portrays the usage of these aspects of C++ pretty well. So without further ado, let's get into the project. So this is it. What this code does is basically it creates a list of people. Each person has their ID and their name, so it's not really something big. And there are also some functions. So you can always add a person, you can print all the people that are in the list, and you can modify them. So let's start from the top. So at the beginning, I define a class called person, and in that class, I define public things. So the public things will be the name and the constructor. And also these two functions are also public, but the ID of each user is private, which means that, well, we cannot get the ID, we cannot read it, and we cannot modify this ID as we could this name. We have to have a special method for this. So we have getID and setID. So how this works is if we want to get this ID, we have created, let's say, an object of a person, and we want to change their ID, or maybe read their ID. What we need to do is we need to use a function, a public function, because a public function does have access to this variable here, to this private variable. So we have to do it via a function. So getID just simply returns the ID of a user, and setID takes an integer, so the integer that we want to set, and it basically here takes this value and assigns it to the ID. Pretty straightforward, but it shows how to deal with private variables inside of a class. They are basically protected by this extra layer of functions. So here we have the name, and as for the constructor, well, when we create a user, a person, we just take as an argument their name and their ID, and here we can assign these things in the constructor. So that's the class out of the way, and the class methods here too. Now we have our three methods or functions, as we can call them. And at the last section here, we have our main function. So firstly, let's talk about these functions. So we have a function called addPerson. So you might wonder, why do we have this function if we already have the constructor for creating users? Well, in this project, we are using a vector, which is an array that simply has a lot of very useful functions, and also you don't have to define how large this array will be. So well, you could say that a vector is like a dynamic array. So in this addPerson function, we get some arguments, and we basically create a new person right here, and then we push that person into our array, and we also increment the iterator, we could say. So what this function does is it gets an I iterator, and you can see this and sign here. I will talk about it in a minute. So it gets some kind of an iterator as the first argument. The second argument will be the name of the person which we want to add. And the last argument, the third argument, is the vector. So this is a pointer to a vector to which we want to add our user, basically. So this, you could treat this basically like an array of, let's say, int array, let's say like this, and int array of 2. This is basically the same thing, but written in a bit more complex way, but it is actually quite easy to understand. I'll explain it just how it works in a minute. Okay, so here we, in this add person, we just at the beginning we create a new person with the keyword new, and we are using the constructor that's defined here in this class. And as we can see, we are passing the first name from this argument and the iterator right from here to this constructor. And the thing is that this constructor, I know that here it does not have any return value. We don't even have the type of this function. Like here we have this function will return an integer, so it is of type integer. This is of type void because it does not return anything. So the constructor, basically, it doesn't have a return statement at the end of it, but it still returns right here from this syntax. It returns a pointer to the person that we just created. So we want to store that pointer in this variable called pointer to person. And this variable is, of course, of type pointer, and it is the person, right? So this is our class, our own defined type. So we want it to be a pointer to a person, basically. So that's the type that we define here, and that's the name of the variable. So now that we have that pointer stored in this variable, we basically take this vector that we received from the argument, and we use a function called pushBack. And what do we push inside of that vector, inside of that array? Well, we push our pointer, of course. Now, that function is not defined anywhere in my code, because this is a function that belongs to vectors. So vectors have their own functions, and we'll see a bit more of them in the future. So you can just type in Google or somewhere in a search browser, right? You can type vector functions. So this is how we basically push values into our vector. We use this pushback function, and we type what we want to push there. So, right, and at the end, so this is basically pushing into our vector. This vector right here, it is defined in the main function of the program. So in the main section right here, which every C++ program has, here we have the vector people. So this vector right here is being passed here in add person, is being passed here, and we are modifying it directly. And at the end of the day, we are also incrementing this iterator variable that we got from the arguments. Okay, so this is add person right here for you. Now, for print people, we simply, this is a void, so it does not return anything, and we are getting this vector array. So we are getting this vector, and what we want to do is basically we want to first check if the vector is empty. So if the vector is empty, we don't want to sort of iterate through nothingness. We just want to say this list, this vector, this array is empty, and this is a very handy sort of command just for cosmetic. So the program will pause here, and someone will have to press a button to continue. So if this if statement is true, so again, this size method returns the size of this vector, which we get through the arguments. If it's 0, if the size is 0, it means that the list is empty, so we just say that on the screen, we pause, and then we return out of this function. So instead of writing a huge big else statement and putting the rest of the code here, I'm just returning out of this function. As it is a void, I'm returning with nothing, but still I'm returning, so this code will not execute because this function is basically terminated at this point. But now, if that if statement is false, if we actually have people in our array, then we are going further in the code. We are not executing this part. We are going further into the for loop, and in here we are doing a basic iteration. So we have an iterator set to 0, and then we are doing it as many times as there are elements in our array. So size always returns the number of elements, and each incrementation each iteration of the loop, we increment our counter, basic for loop. And here it's a bit tricky because we can access the name with no problems. Like we could access any variable of a class, any public variable, but here we have to, in the ID section, if we want to print the ID to the console, to the screen, we need to use this special function that returns the ID. So as you can see, we are using this array. So this array has a special method called @. This is basically the same as we have with normal arrays. So for example, we have array at, let's say, cell number 2. So this will return, if this were a normal array, it will give us basically this value at cell number 2 in this array. And in vectors we have @. So instead of writing this, we are writing array and using the function @2. So this is basically the same, just tiny changes here. And so we want to say at this cell in the array, let's say this is the first loop, so at cell 0, because I will equal 0. We have a pointer because this vector has pointers in it, pointers to our people. So at this pointer, this is a special syntax for pointers, because at this pointer we have 2 values. So we have, or rather not 2 values, but all the values that our person has. So we have all these methods and all these variables, some private, some public. So at this place, we want to get the name. And then we print ID, and then after that, we again go into our pointer. We see that under this pointer, we want to get this function, getID. So this function will basically return the private ID. We couldn't write ID here because this is a private value, so we do not have access to it. Instead, we are using this function that I have defined previously that simply returns right here, returns that value. So then we do end line, and at the end of the print list, we are pausing. So that's this function. And now we have modification of the person. So at the start, we basically want to modify a person. So we want to, right here, we want to get this array. And here, we want to get this given ID. So for example, we have a list of people. Let's say that we have Kate with ID of 12. We have Mark with ID of 24. And we have Jacob with ID of, let's say, 2. So we have this list of people, and we want to modify one of them. So what do? Well, of course, we pass in the ID. So we say, let's edit someone's values. Let's edit the person with the ID of 24. So then we can edit the name and the ID too. So this is what this function basically does. We get the ID, so ID, for example, 24, someone, and we get the whole array here, our whole vector. So at the beginning of this function, we are simply creating a pointer to a person, which we set to be null for the time being. And then we also reserve some space for a new name and new ID that will possibly be occupying if that person is found. Then we have a for loop. So in that loop, we are checking whether this person with such an ID exists on our list. Because if someone gives an ID that he or she wants to edit a person with a non-existent ID here, so for example with an ID of 54, well, we don't have such a person. So it would be good if our function simply returned or didn't or recognized that such an ID doesn't exist in our list and told the user about this. So this is exactly what's happening here. Our function iterates through the list. This is the same thing that we did previously. And in there is just one if statement. So if array at the current iterator and get ID, so we basically get our ID from this, is equal to the given ID, so the given ID with which we identify the user which we want to edit. If it is equal, so if we have actually found such an ID, we want our person pointer to point to this person. So this part of the code basically just returns a pointer because this array is full of pointers. There is nothing but pointers in this array. So at this section, so for example, at 2, at cell or point in the list number 2, we have an array to the person, which we save into our person variable. Okay, so now after this loop ends, let's say that we have given such an ID that didn't exist. So this if statement didn't occur. Our pointer after that will still be null. Why? Well, because this if statement did not run, basically. So the person variable, it still has the same value because nothing else was put in it, right? If this statement wasn't executed. So here we are checking for it. So if it still is null, that means that this if statement wasn't run, which in turn means that there is no person with such an ID in our list. So we are typing that information out. User with the given ID was not found. We are pausing and returning out of that function. So past this code name, nothing else will occur, basically. And now one important thing to remember is that if I just define this variable like this, then we'd have a problem because this person right here, let's say that we are defining this just like this string or this integer. Well, this person right here could actually, this is a pointer, so by typing that we want this person to be null, we are ensuring that nothing else is in here. We are making sure that this person pointer stays empty. It's very important because if we actually, if we reserve this space, it might not be empty. I'm not 100% sure. It might be still null, but this is making extra sure that this is not filled with some random pointer from our RAM memory. So basically, if I did this, there might be and didn't pass the null value into the person pointer. Well, basically there might be some other pointer in there, just automatically assigned some garbage. So then our if statement would not run because there would be actually something in the person pointer. So yeah, then we'd have a bit of a problem because we do not want to execute this code if we don't have a person, right? So let me just correct this. So it's very important. If you assign a new pointer that you want to fill later on somewhere in your code, always remember to assign it to a null value, especially if you check later on if it is actually null. Okay, moving on, we are doing some basic C++ stuff. So we are getting the name and the ID. So we are putting these values into our earlier reserved values for that, or variables, I should have said. And then at the end, we are basically setting the ID. So we are using set ID and passing that new ID, that integer, into that function. So what this does is this is a pointer, and we want to say at this location to which this pointer points, just put at the name in this location in the RAM memory, set this name in this location to new name, and here set the ID to the new ID at this location. Remember, this is a pointer. It points to a specific location in RAM. So in this location we have name, right? We have a variable called name, and we set and I want to say at this location, at the section name of this location, we want to store our new name. And here at this location we have a function. I want to use it, and in here I pass my new ID. And in this function we take that new ID and we assign the ID to the new ID. Basically, that's how it works. Okay, this is the end of the modify person function. There's nothing else to do here after we set these values to our variables. Now let's head on over to main. So here, let's talk a bit about that vector. So this is the place where all our people will be stored. Now, vectors work like this. They are basically arrays that are dynamic, which means that I can basically I don't have to type any sort of amount of cells that I want to reserve in this vector. If we had a normal array, so for example an integer array, let's say int r, and we'd have to type in 2. So here we have 2 cells in that array, and it is fixed. We cannot add anything more to this array. 2 is the maximal limit. Of course, some people just type in int 1000 and pray that nothing else will be needed to be saved there. But this is a horrible, actually, memory loss, and it's much better to have a dynamic vector right here to allocate as much memory as we need at the given moment. So also we define what type of objects we want, of what type of variables we want to have in our vector, like this. So we type vector, and here we have these two greater and lesser than signs, and we type, for example, int here, and we give our vector a name. So let's say test. So that's how it works. We have now a vector of ints. The same way that it would be defined here would be int array of some kind of size, and this is basically the same thing. But of course, our vector can hold as many variables as we want, not just 2 or a predefined number. That's the biggest difference. That's why we are using vectors. So now that you know what these two signs mean, you can see that we basically store pointers to our person object. That's how we designed our vectors. We want to have a vector or an array full of pointers, and pointer always has to have a type to which it is pointing. So if we are pointing to some integers, that would have to be an integer pointer. But we are pointing to our person object, to our person sort of new type that we have defined, our new class. So that's why we are typing here. We want a pointer to person, and we call this people. Well done. Now, the variables that we have reserved here is the iterator, the input, and the name. So the iterator is basically a variable that we increment, and we want to store, we want to use it to create new IDs for people. So if someone adds a new person, that iterator is used to basically create a new ID for them. So if we create a first person, they'll have an ID of 0. If we create a second person, then they'll have the ID of 1, etc. So we increment that iterator right here in this add person function. And yes, I haven't forgotten, I'll still explain how this and sign works and how this little piece of code can actually have an effect on our main iterator right here. So yeah, later on we have input and name. So basically I have created a little menu here for us. So I want this menu to run as long as the input, which someone inputs here, as long as it is not equal to 0, and I want it to run at least once. That's why I do it in a do while loop. So this do code will execute at least once, and if someone decides, no, I don't want to run this program, then it will close automatically. Anyways, that's a character here. So we are couting, we are writing our menu here, all the options, and if someone presses 1, well, I have a switch statement. So here someone inputs 1, and that switch checks for all the cases here. If we have case 1, then we basically enter the person's name and we go to our add person function, which I have described previously. So this is a very basic menu, and what is important is that you might ask, why have I created a car variable or character variable if I actually have numbers here? Why isn't it in an integer variable? Well, the thing is that if you actually input these, if you wait for input and someone presses a character, like for example a letter D or letter F, and we would have an integer input here, that would freeze the program and basically create a lot of problems for us. That's why it's basically safer for this little menu to have a character input, because then at the default section we can just type incorrect input. Okay, this is basically the entire program. So now the last thing to do would be to say, how can I actually edit these? Why do I type this end value here? So this is actually very important, because if we have well, let's say we have this iterator and we want a certain function to operate on it. So we want a function to get this iterator value, and let's say add some value to it, and we want this actual iterator in our main function to be affected by it. So if we have a function right here, this add person, and we get this integer. If I didn't put this and sign here, I would simply get a copy of that iterator. I would get a copy. So the compiler would check what value this iterator is. So it would check, okay, the iterator that I am passing into this function is 0. So it would make a copy. Okay, this I is 0, and then inside of that function it would just add 1 to our copy. But this would not affect our main iterator, right? So here, what I need to do, I need to type this AND value, because then we sort of tell the compiler that we want to operate on this iterator. We want to affect it. We don't want to get a copy. We want to work on the original, and we want to be able to change the original. I do the same thing with the vector. If I pass the vector somewhere into our function, let's say that I want to add a person to our vector. So again, in the add person, I am actually right here getting this. I'm telling the compiler I want to work not on the copy of the vector, but I want to modify and affect the vector itself that I passed. So this vector, because I pass it in add person right here. So these people are being passed right here. So I want to say basically that I want to affect it directly. So here we can see we are doing array, so this vector push back, and we are pushing to this vector, not to a copy, but to the vector that I passed in. So also to kind of explain what it means, if we have an integer, let's say test equals 3, and this basically says that at the this basically reserves a place in our RAM memory and places number 3 in it. So if we want to get an address to it, the way we can do it, we would cout and test. That's how we get the address. So here, instead of 3, we will get the address, the memory address, which probably looks like this, like some kind of weird name for it. But this is basically what it gives us. And if I, of course, typed this, well, then we would get 3 printed out in the console. So that's the way to basically get the address of anything. That's why we use this here. We want the address. We want the literal, we don't want the copy, we want the literal address. We want to modify things at the address that was passed here. So that's how we do it. And of course, if I wanted to save that test variable somewhere, I would need to type to save it into an integer pointer, test pointer. I'd give the name to it, and here I'd save the test variable, the address basically, into that pointer. That's how pointers work. I know they might be a bit hard to wrap your head around, but believe me, it's worth it. In C++, it's an absolute must. So basically, that's the whole code. Now let's present how this will work. So I'm compiling it here. Or maybe I'll press OK. It's a bit slow because I'm recording. So, okay, our program is running in the console, and actually, let's make it larger. Okay. There we go. So here, as you can see, I have the menu written for the first time, and let's say that I want to view the people that I have in my list right now in my vector. So I type number 2, view people. List is empty, right? Well, that works because our list is indeed empty. So let's try to add some people then. So we type 1, enter the person's name, let's say Kate. And there we go. We don't enter the ID because the ID is kind of automatically generated through this iterator. variable that I showed you before. So let's view the people that we have now. There you go. Name Kate, ID 0. That works. So now let's add one more person. Let's say John, and let's give, well, we cannot give him an ID, so just press enter. Let's view the people, and here we go. Name John ID of 1. So you can see that this iterator is actually being incremented. Now let's modify person. What would be the person's ID? Well, let's say that the ID will be 300. Of course, we don't have such an ID. So, as we can see, the user with the given ID was not found, and press indicate to continue. So, what IDs do we have? Well, we have ID 0 and 1, so let's modify the person with the ID 0, and the new name of that person should be, let's say, not Kate, but Kate2. And we can also enter a new ID. So let's say 23. Let's view people. Here we go. Name Kate2, ID 23. So it was actually saved. And as you can see, Kate is still first in our list because what we did, we only modified the values. We didn't modify the pointer. The address of Kate, or of Kate2 now, is still the same. So that's how it works. And we type 0, we exit. So basically, that's it. If you have any questions or if my explanation was a bit too long and chaotic, please write it in the comments. I'm happy to answer all your questions. You can also pause the video and rewind it if you're not sure what anything means. But the best way to learn this would be basically to write it yourself, try to maybe copy my code and see how the compiler reacts to your changes and what the errors are. Okay, thank you very much for your time, and until next time.